Hello Year 7s. Today we're talking about how to find the LCM using factor trees. So just to remind us, yesterday we found the HCF, or the highest common factor, using factor trees. So for example, what's the highest common factor between 48 and 60? I did a factor tree for 48 and I did a factor tree for 60. And then remember, you stop when you get to all the prime numbers. And then when I was done with the two factor trees, I highlighted all the factors that were in common. So there was a pair of 2's there, then there was another pair of 2's there, and there was a pair of 3's there. Okay. Now the things that weren't circled were the two. There's a 2 here and a 2 here, but there wasn't another 2 that I could put on the 60. Okay. And then to find the highest common factor, all that you did was that you times all the numbers in one of those trees. So I only did it for 48. So 48 is, if you see the ones that we highlighted, it was 2, 2, and 3. Okay. And the same for the 61. It's 2, 2, and 3. Okay. So if you just look at one of those trees, the ones that you highlighted as being the same, when you multiply all of those together, you get the highest common factor. And we did two examples there to show us how to find the highest common factor. But today we're not trying to find the highest common factor. In fact, what we're trying to do is find the lowest common multiple. After we do this, we are going to look at some word problems. Okay? So, example, what is the lowest common multiple of 48 and 60? So let's quickly do the factor trees for 48 and 60. Okay, so 48 and 60. So I can break that up into, let's say, 4, and what's the other digit that I could put in there? And 12. Then I could break that up into 2 and 2. I could break this up into 6 and 2, which the 6 I can break up into 2 and 3. And all of these numbers that I'm left with are all prime. That 6 is not prime. That still got split up. So 48 is 2 times 2 times 2 times 2 times 3. Okay. So there's 4 2's and 1 3. So that's all good. And let's look at 60. I could call that, let's call it 30 and 2. 30, I can break, 2 is a prime number, so I'll stop there. 30, I can break up into 15 and 2. 2 is a prime number. 15 I could break up into 3 and 5, because 3 times 5 is 15, and those two numbers are prime. And as you can see, in 60, we've got 2 2's, so there's 2 2's that they put there, 1 3, and a 5. Okay. So at the end of all of this, you know that 60 is the same as 2 times 2 times 3 times 5. And there's all the prime numbers. Okay. Now, when we find the lowest common multiple, once again, we are going to highlight the numbers, or the pairs of numbers that are the same in both of our trees. So let's go ahead and do that. So I see there's a 2 in this tree, and there's also a 2 in that tree. There's a 3 in this tree that can also get paired up with that 3. Is there anything else I could pair up? Yes, there's another 2 that I can pair up with this 2. Is there anything more I can do? No. Okay, so these two 2's, there's no friend I could pair it up with anymore. And that 5, there's no friend I could pair it up with this one. Now, when we find the lowest common multiple, what we have to do is times all the ones that are unfriended, so all the digits that are left out, and all the digits that are highlighted in one of those trees. Okay. So let's see how I find the LCM. To find the LCM, okay, you would say that the LCM equals, remember, all the digits that are unpaired. So what digits do we have there? 2, 2, and 5. So 2 times 2 times 5. Okay, so those are all the ones that are unpaired in both of the trees. And then only one of the trees that is highlighted. So then I still need to add to that 2 times 2 times 3. times 2 times 2 times 3. Okay? And then, if you get your calculator out, you could work this out. But first, let's write this in index form. How many 2's have I got? 1, 2, 3, 4. So that's 2 to the 4 times by 3 times by 5. Okay. But if I wanted that just as a number, what would I do? I'll pop that in my calculator. 2 times 2 times 2 times 2. So that's 2 4 times 3 times 5. And you get 240. Okay. And that's exactly what they got there. They said 240 is the lowest common multiple of 48 and 60. So just to repeat what we do to find the lowest common multiple. Do your factor trees, highlight the pairs of factors that are the same, and then the last step, to find the lowest common multiple, multiply all the unhighlighted bubbles with all the highlighted bubbles in one of the trees. Okay? So that's how we do it. So, what I'm going to do now, if you think you want more time and me doing one more example, I'm going to do this top example and you can follow along. But then this bottom example I'll also do, but you decide when you want to pause it. If you want to pause it now to see if you can do it by yourself and then check the answer, go ahead. So I'm going to start this top one in 5, 4, 3, 2, 1. Pause if you need to, but here's the answer. Okay. So, using prime factorization, find the lowest common multiple of 25 and 50. So I have to do this using the factor tree method. Okay. Because it said there, using prime factorization. So, what was the first step? The first step was that I needed to have my two numbers and I had to make two factor trees out of it. 25 is the same as 5 times 5. Okay. Is 5 prime? Yes, it's prime, so I stop there. What about 50? Well, 50 is the same as 5 times 10. I know 5 is a prime number. What about 10? Can I break that up? Yeah, I could break that up. I could break that up into a 2 times 5, because 2 times 5 is 10. Are those numbers prime? Yes, 2 is prime and 5 is prime, because I can't split that anymore. So there I've done the first step. I've done my factor trees. The next step was to highlight all the common factors, all the pairs of common factors. So I see this 5 can be friended up with that 5, and this 5 can also be friended up with that 5. And then the last step was to multiply all the unhighlighted bubbles with all the highlighted bubbles in one of the trees. Okay, so the LCM equals one of the unhighlighted ones, so 2, times by, now I need to check with the other one, 5 and 5. So all the highlighted bubbles in one of the trees. So 5 times 5. Okay. So let's do this. What's 2 times 5? 2 times 5 is 10. And 10 times 5 is 50. Okay. So the lowest common multiple of 25 and 50 is 50. Okay. I'm now going to do this example. If you would like to pause the example to try by yourself so that you could see the answer, pause. I'm starting in 5, 4, 3, 2, 1. Okay, 80 and 50. I have to do the factor tree for these two. How can I break up 80? Oh, well, that's the same as 2 times 40. 2 is a prime number. 40, what can I do with 40? Can I break that up? Yeah, that's the same as 4 times 10. And what about 4? I could break that up into 2 and 2. And 10 I could break up into 5 and 2. I just want to remind you that your factor tree might look different to mine, but so long as the numbers that you have at the end are the same as mine, you have done it right. So if you have 1, 2, 3, 4 2's, and 1 5 at the end, you have done your job right. Okay, so your tree might look different, but it's probably the same. Let's do 50. Well, that's the same as 2 times 25. And I know 2 is a prime number. What about 25? Oh, I could still break that up. I could break that up into 5 times 5. I'll stop there. 5 and 2 are prime numbers. Okay. Now, that's step 1. Step 2 is highlight all the pairs that are common. So I see there's a pair of 2's there. So let me highlight that pair. Is there a pair of 5's? Yes, there is. There's a pair of 5's. And is there any other thing I could highlight? No. Remember, to find the LCM, all you need to do is, for the 300th time, multiply all the unhighlighted bubbles. So what have we got there? We've got 5, 2, 2, and 2. So 5 times 2 times 2 times 2. 1, 2, 3 2's. 1, 2, 3 2's. So multiply all the unhighlighted bubbles with the highlighted bubbles in one of those trees. So you can pick which tree. They're the same thing. I'm going to go with this one. So what am I left with? 2 times 5 times 2 times 5. Then you just need to stick that in your calculator. Let's see what we get there. 5 times 2 times 2 times 2 times 2 times 5. Just make sure. 5, 2, 2, 2, 2, and a 5. Press equals, and I get 400. So 400 is the lowest common multiple of 80 and 50. Okay. That's how you find the LCM. Now we're going to look at some word problems that we can do, which we have to then figure out, well, what do we have to find? Do we have to find the highest common factor or the lowest common multiple? The notes that you took on this page over here will help you with some of those. One of the hints is, if it's got the word lowest in it, okay, then you'll probably need to find the lowest number, the lowest common factor. Okay? Also, the lowest common multiple, sorry. Also, if it's got something to do with time, and they ask you when's the earliest time that it repeats itself, it's also the lowest common multiple. On the other hand, for the highest common factor, if you've ever got a situation where you have to arrange things into rows, then you know you need to use the highest common factor. Or if you ever have getting yourself in a situation where you see the word greatest or highest, then you're probably going to have the highest common factor. That's what you need to do. Okay. I'm on page 22 right now. Let's read what we have to do. For each problem, decide if the highest common factor or lowest common multiple needs to be calculated. Then draw the factor trees, and then calculate the highest common multiple or lowest common factor. Let's look at some of these problems. Pencils come in packages of 10. Erasers come in packages of 12. Philip wants to purchase the smallest number of pencils and erasers so that he'll have exactly 1 eraser per pencil. How many packages of erasers and pencils should Philip buy? We have to choose one of those, so we'll come back to that. Let's actually do this problem. To solve this problem, do you use the highest common factor or the lowest common multiple? Have a think about this. They asked for the smallest number of pencils and erasers, so I probably want to find the lowest common multiple in this example. Okay. Next thing they've asked me to do is to construct the factor trees and prime factorization in the space below. Now I need to make 2 factor trees here. Okay. What numbers am I going to use? I'm probably going to use those 2. So I'm probably need a factor tree for 10 and 12. 10 is the same as 5, which is a prime number, times by 2, which is also a prime number. So 10 equals 5 times 2. And 12 is the same as 6 times 2. 2 is a prime number. Can I break up 6? Yeah. That's the same as 3 times 2. And those 2 numbers are prime. So 12 equals 2 times 2 times 3. Okay. I've done my factor trees. Now it says use the prime factorization to calculate the lowest common multiple. Okay. let's have a look. Remember what we did next was we highlighted the pairs. Is there a 5 that I can highlight in both trees? No. What about a 2? Yeah, there's a 2 here. Okay. Now, let's figure out how to find the lowest common multiple. Use a prime factorization to calculate the lowest common multiple. Remember what we do. Multiply all the unwanted bubbles, or all the unhighlighted bubbles, with one of the bubbles that has been highlighted. So, the LCM equals, what are we going to have here? 5 times 3 times 2. Those are all the unhighlighted bubbles. Okay, so 5 times 3 times 2. And then I need to multiply it with the highlighted bubbles in one of the trees. Good, good, good. So that's another 2 that I need to add in there. Pop that in our calculators. 5 times 3 times 2 times 2. 5 times 3 times 2 times 2. That gives me 60. Okay. So what does that tell me? 60 is the lowest common multiple between 10 and 12. So I'm probably going to need 60 pencils and 60 erasers, and that's the first time that those two things will be in common with each other. Okay. So, how is this helpful when solving for the number of packages of pencils and erasers? Well, I know that I need 60 pencils. Okay. So I know I need to find 60 pencils. So how many packets of pencils do I need? Well, pencils come in packages of 10. So I know I'm going to need how many packages? Oh, well, therefore, 3 dots for therefore. Therefore, I need 10 packets of pencils. Okay. And you could say the same thing for the number of erasers. I know I need 60 erasers. Therefore, I need, well, how do I get 12 to become 60 by timesing? Well, how many packets am I going to need? Well, isn't 5 times 12 60? Yeah, so that means that I need, 10 packets. I need 6 packets. How did I make that mistake? Anyway, so I know I need 5 packets of erasers. Okay, so let's see if I can solve this problem. Which one is it? I need 6 pencils and 5 packets of erasers. 6 pencils and 5 packets of erasers. So the answer is C. Okay. That's one word problem, finding the lowest common multiple. This example I think we've done before. I'll just finish it up in case you haven't. This one you had to find the highest common factor. So remember, when you find the highest common factor, all you do is multiply the pairs that are the same. Okay? So I highlight all the pairs that are the same and then just multiply the pairs. So this is different to the LCM. What pair do I have there? I've got a pair of 3s and a pair of 2s. So only look at one of the trees and just say, oh, well, that's the same as 3 times 2. 3 times 2, which is 6. So 6 is the highest common factor here. So to finish this word problem, you need 6 cookies per container. Okay, that's page 23. We are so close to being done. Let's have a look. Let's look at example number 3. Remember, we have to figure out, do we need the lowest common multiple, the highest common factor? That's our first step. Boxes that are 24 centimeters tall are being stacked next to boxes that are 36 centimeters tall. What is the shortest height which the two stacks will need to be the same. So obviously here I have to find the LCM. Okay. To find the lowest common multiple, I first needed to do two factor trees. What numbers do I need to do the factor trees on? Oh, 24 and 36. So let's go ahead and do that. 24, 36. Boom, 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 boom. 24 breaks up into 2 and 12. 2 is a prime number. That breaks up into 2 and 6. That's a prime number. And that breaks up into 3 and 2. And those two are prime numbers. Looking at 36, right? This one that I've got here is going to be the same as, what are we going to have here? 6 times 6. Okay. And 6 can be broken up into 3 and 2, which are both prime. And the same with this one, 3 and 2, which are both prime. Okay. So, how did we find the lowest common multiple? It was super easy. You had to highlight all of the ones that were the same. There's a 2 here, there's a 2 here, there's a 3 here, there's a 3 here, there's a 2 here, and there's a 2 here. There's nothing more that I could do. Okay. Then right at the end, don't forget that you need to do something where you multiply also to find the LCM. Multiply all the numbers that are unhighlighted. So 2 times 3 with all the highlighted ones in one of the trees. 2 times 3 times 2 times 2 times 2 times 3. Pop that in your calculator and you get 2 times 3 times 2 times 2 times 3, 72. So the shortest height of the two stacks will be 72 centimeters. Okay. Let's look at the next example. Beginning at 8:30 a.m. Tours of the Supreme Court and Government House begin at a tour agency. Tours of the Supreme Court leave every 15 minutes. Tours of the Government House leave every 20 minutes. How often do these tours leave at the same time? Okay. Well, to find something like this, I need the lowest common multiple. Okay, because I want to find. This is one of those situations where you've got time and you've got something repeating itself. So you want to find when you've got common times or the lowest common multiple. Okay. What are the two numbers I'm looking at? These two numbers. So what's going to be the lowest common multiple of these two? Let's do a factor tree quickly. 15, 20. 15 breaks up into 3 and 5. They are both prime numbers. 20 breaks up into 4 and 5. 5 is a prime number. 4 I can break up into 2 and 2. That's all done. Which of these are common? Well, that 5 and this 5 are common with each other. How do I find the lowest common multiple? The lowest common multiple, LCM, is going to be, remember, all the unhighlighted bubbles, so 3 times 2 times 2. With all the highlighted bubbles, what highlighted bubble do we have here? We have a 5 in there. Okay. Looking at this, what we need to do now is we need to find the lowest common multiple of this one. So let's go ahead and do that. 3 times 2 times 2 times 5. That gives you 60. Okay. 60 is the lowest common multiple, so that means tours leave every 60 minutes. Good. Okay. Moving on to the next problem. Yay! Woohoo! The table below shows the number of students in the school choir for presentation night. In year 7 there were that many students. In year 8 there were that many students. The choir teacher plans to arrange the students in equal rows. Okay. Whenever you have to arrange things in rows, you want to find the greatest common factor. Okay, so go back to your page of words that you had on page 18. So you have written down some words there. And then see one of the key words. Anytime you have to arrange things in rows, you need to find the greatest common factor or the highest common factor. The choir teacher plans to arrange the students in equal rows. Only year 7s or 8s will be in each row. What is the greatest number of students that can be in each row so that each row has the same number of students? Okay. Well, we need to find the highest common factor. So straight away, we need to do two factor trees. So 176 and 160. Let's go ahead. Let's do some factor trees. Can I break this up? Yeah, it's even. Okay. So I know that this is even, so I know it can be 2 times something. I'll get my calculator to see what that is. 176 divided by 2, and I get 88. So it's 2 and 88. Is 2 a prime number? Yeah, it is. 88, can I still break that down? Yeah, sure. Let's go ahead. Take in this 88. 88 is the same as, well, that's once again, I could say 8 and 11, because 8 times 11 is 88. Oh, any of those prime? Yeah, 11's prime, so let's go ahead and circle that. What about 8? Nah, I could still keep going, break that down even more. 8 is the same as 4 times 2. Okay. Oh, any of those prime numbers? Yeah, that one's a prime number. Boom, boom, boom. What about this one here? That's a 4. Oh, I could still keep going, so that's 2 and 2. Done. And I'm done with that factor tree. Let's do 160. Oh, well, 160 is the same as 2 times 80. And 80 I could break down into 2 times 40. 40 I could break up into 2 times 20. 20 can break down into 2 times 10. 10 can break down into 5 times 2. Okay. Oh, look at this. Now I can find the highest common factor. What did we do next? Oh, we highlighted all the common pairs. So look at all the bubbles and try and find the common pairs. That one's done there. Is there an 11 in this other tree? No, there's no 11. What about the 2? Oh, there's another 2 that I can find a friend for. Let's go ahead, highlight that. The 2's, yep, I can highlight that 2 with that 2. And then I need to highlight this 2 with this 2. Okay. Now, what do we need to do at the end? To find the highest common factor, all you do is you multiply all of the numbers that are highlighted in one of the trees. So, highest common factor is 2 times 2 times 2 times 2. 1, 2, 3, 4. There's 4 2's there. If I pop that in there, I get 2 times 2 times 2 times 2. I get 16. So to answer the question, what is the greatest number of students that could be in each row, so that each row is the same number of students? 16. Okay. There we go, girls. That is the highest common factor and the lowest common multiple. If you go on to Jack Plus, there is an assignment for you for homework. I suggest that you get started with that. Thank you.